Okay, so this is our demonstration video for our EE Senior Design project. First off, we have 5 volts power coming from the Raspberry Pi to both rails of the breadboard. This 5 volts then goes to a boost converter to convert the 5 volts to 48 volts that will be used later on for the phantom power of the microphone. Speaking of the microphone we have attached right now is just a simple demo microphone that we used during testing to ensure we didn't damage any expensive microphones. It disconnects here for easy connection with a clippy XLR that we will ultimately use for a demonstration. The microphone plugs into this pigtail connector that allows us to separate the ground pins and the analog positive and analog negative signals. These signals attach to that phantom power circuit to provide the phantom power necessary for the microphone to operate. They also go to a set of decoupling capacitors you see here to decouple the AC signal coming from the positive and negative lines from the DC power that powers the microphone. These AC signals go into the operational amplifier that amplify the signal up to a readable voltage for the ADC. Gage will talk about the ADC and the Raspberry Pi.
For the ADC, we're taking that same signal that we're getting from this microphone, and we're going straight to this ADC. Through this ADC, we'll convert it to go from our analog to digital signal. And the program will actually use this button. So you'll run the program. It'll say like, hey, ready to record, press the button. You'll press the button, the light will turn on, and it will start recording the program. You can preset it to have a certain amount of recordings and record each .wav file for a certain amount of time. So let's say you wanted to record the WAV file for 5 seconds, you'd put that in there along with obviously how many recordings you want to do. So from there, it'll take that incoming data from the ADC or from the XLR, convert it, and then send it over here through SPI. We also ended up using another chip. This one actually uses I2C as opposed to this one using the SPI. The same idea, the microphone will come into here. It'll ask like, hey, push the button to record. So you'll push the button, the light will turn on saying it's recording. It'll go through the ADC, and the same deal go straight to the through the Raspberry Pi so it can make a .wav file and ultimately put that in a directory.